Hello everybody. So, today's video is about my 3D printer enclosure and not really how to build it, but more what I think is important when you're building a 3D printer enclosure and kind of how I solve some of the various problems that arise when you're building a 3D printer enclosure. I don't really have plans for it, but I really hope that this helps someone else building their 3D printer enclosure and just I don't know, it's kind of cool. I'm kind of proud of it. It's my second iteration, and it came out really good. So, without further ado, the 3D printer enclosure. Alrighty, so I guess the first important part about my enclosure is actually this frame here. So, I'm going to post some pictures that are appearing now. Alright, so you're back, and basically from those you can kind of tell that the way this works is I've got a bunch of 2x2 select poplar sticks here, and these make up my legs, and then I have a bunch of select 1x2s that make up kind of a square frame behind it, and then this, whoa, that light is a bit much, and then a 2x2 down the center, and that is mirrored up here and below this chunk of paint. I think it's like paint grade plywood. It's really nice. It's like, you know, about a 1/4 inch thick, really sturdy. Just like $20 for the whole sheet. It's perfect. Now you can see I put everything together with 3D printed brackets. Yeah, there you go. There's a good shot right there. You can kind of see that one. Each one takes either 4 or 8 screws, depending on where it was. And the actual strength of this does not come from those. Those just to hold it together, just enough to put on all of these plywood panels. Now, these plywood panels are, let's turn up the brightness a little bit. These plywood panels are 1/8 inch Luan, and you can see I put a screw pretty evenly. And you can't actually buy a sheet of plywood that's big enough to cover this whole thing, so I had to do it in 2 pieces. So that's actually why there's a center stiffening member down the center. If you can actually purchase plywood at 4 foot by 8 foot and actually put it in your vehicle, then you don't need these center braces. But basically this gives it essentially the triangle support, so that, I mean, this is really nice and sturdy. The only reason this is really wiggling is because the legs are kind of spindly, but I'm fine with that. So yeah, I mean, it's all just kind of screwed together with these little wood screws. I mean, it's a box, right? It's not much else to talk about. I'm hoping someone will comment with questions if they have any specific questions. I'll lead with, no, I don't have plans. I probably could draw some up, but like, you know, I could probably draw some up. Probably not a bad idea. Anyway, so door. So now for the door, I really... come on. There we go. Sorry, still trying to learn this camera. So the door is a bunch of the select 1x2 dropped in a square, and then I just use this foil tape here to hold on the piece of plexiglass, because on my previous enclosure I drove screws in pretty regularly, and it was a pain in the butt because wood you can really clamp down on, and then plastic you can't, so you ended up with this horrible cracking all around the corners, and it got really sharp, and I'd cut myself, and bleh, not worth it. So I just basically just sat it down on the floor, pressed down, and ran the foil tape, and it works awesome. Like, this is perfect. And you can see I actually strengthened it a little bit with a second 1x2 there. It's actually for these little door closey bits here. So don't actually need those anymore though, because in my old enclosure the door would actually flip up and then it would actually stand nicely like this. But this one, I don't have enough room to my ceiling, so I use these gas springs. And I mean, these things work awesome. And then the door just hangs out nice and vertical. And then when you close it, it's really nice because as soon as the angle gets to here, it actually is holding the door closed. So it's really nice. I'm a really big fan. So the next important thing is drawing negative pressure on the enclosure. So what I do is I have a constant speed 12 volt fan, which is running behind this parts box here and vents out the door. Light is not doing great, but you can kind of see right there where it exits. And so this entire section of ductwork here is under negative pressure, and therefore drawing air out of this box. Now, the box is not airtight, so I don't really need to do this, but you can kind of see way in the back there. If I open this door, see how the little piece of red flappy bit closes and now it opened? So I use that to maintain a constant negative pressure in here, relatively regardless of airflow. And that lets me open up this servo butterfly valve, which right now is just a manual butterfly valve I just open and close. But I can adjust the amount of airflow going through the box, but I can maintain a constant negative pressure. So this is awesome for doing ABS or things because you always get negative pressure. However, you can choke off the flow and really get the temperature nice and warm inside of here. Works awesome. This is how my old enclosure worked, and I liked it enough to go through the hassle of doing it on this one. So highly recommend it if you have the patience to set it up. I'd say the next important thing is keeping the enclosure electronics cool. So I have... there are many solutions to this. The easiest would be to wire it outside the box. Amazingly, I was too lazy to do that, so I designed a bunch of air ducts, which wasn't easier, honestly. But I've got this 80 millimeter fan here, which blows air into the grates that are on the side. I use tape to fill in all the other grates, and so air comes in, goes into there, and then gets pushed out the back through this, which has a little grate behind it. And it works really well. I mean, you're blowing way more air than was intended across the thing, and it's... I mean, like, the box doesn't even get warm anymore. So, I'm a big fan. It seems to work really well. And, yeah, it's really important to keep that electronics cool in there because the things that will actually go bad are things like capacitors, and when they go bad, they're going to make smoke and fire and bad news. Alright, so the next important thing is actually fire suppression. So 3D printers are really just a heater with a fuel source behind them, and if things go wrong, you're basically just feeding a heater with fuel. So I actually have two solutions in here. What you're looking at right now, this little automatic fire out thing, is actually my, hopefully this never is actually necessary. I really am not even sure they work. There'll be a fun video sometime of me actually trying to get that to work. But I figure it's better to have it than not have it, so I got one. The main source of fire suppression is the smoke alarm, because actually the nice thing about smoke alarms is that usually you get smoke before there's a fire. So this is going to detect that there's a problem far before there's really open flames and just all-out combustion. And what it's done is this is one of the wire-in models, and it runs a cable all the way down to this, which is a relay that when that smoke alarm goes off, it actually unpowers the power brick, which is holding the relay closed, and shuts off everything. So we're talking the Octoprint Raspberry Pi. It shuts off the 12-volt exhaust fan. Everything, the light goes off, so that if anything is going wrong on this thing and smoke is detected, one, the vent fan closes, so I don't get more flow into the box, more airflow into the box, and it basically it should be really effective. And believe it or not, I actually got the chance to test it yesterday. I was using a Dremel kind of back in here, and was making a little bit of smoky smell, and then all of a sudden I hear beep, and the case light went out. So, yeah, it works. And as you can see, I'm printing a little bit of PETG right now. It's a part for an FRC robot, which I cannot disclose anything else about. Alright, well, that wraps everything up. Yeah, that's it. Thanks for watching, and hopefully I'll have some other totally random content for you next that has tinkering interest. Still trying to figure out what this channel's about.